Oh my goodness, energy problems. You can't remember how to do energy problems? Well, here we go. We have a roller coaster here and it's moving at 2 meters per second and it's 10 meters above the ground. And what we're going to do is we're going to try to find out the velocity at point B. And we'll also try to find, we can find the velocity here at point C. And we can also find this maximum height here at D. We can do all that stuff with this equation that I have below here. What we have is that all the energy before, the kinetic energy, the potential energy, and plus the work, because work is the ability, or because energy is the ability to do work. Those three things are the total energy before. And since energy is conserved afterwards, they'll be equal to the kinetic energy and the potential energy. So I broke them down into the equations. Kinetic energy is 1/2 mv squared. Potential energy, and we're using gravitational potential, is mgh. And then work is force times distance. Okay, this didn't tell us a mass of this little roller coaster. And so when they don't tell you a mass, just make up a mass. I make up 1 because 1 is the easiest number to use math-wise. And why not use a 1? Don't pick 0, but pick 1 or pick 10 or pick 100. Pick something easy. 1 is the easiest. Okay, so we're just going to plug this in. We're going to start. Our first condition is right here. Start with this. That's where all the energy is. Now, there's no work in this problem. But if there were work in this problem, if it said there was friction over the distance of this whole thing, it would tell you how much force it was, and it would also tell you the distance that force was forward or against it. Maybe something was pushing it, maybe something was stopping it, but it would tell you. Okay, so let's not worry about that work because I don't see any work on this problem. Right, so we're not going to need that. Okay, so here we go. Let's use blue. All right, so we have 1/2 times the mass, which we said was 1, and the velocity squared at that point would be 2 squared. Right? Plus the mass is 1. Gravity, I use 10 as gravity, so if you're not in my class, ask your teacher what you should use. I like 10, and the height is 10. Plus, there's no work involved, and that equals whatever condition we're going to. So now I'm going to go to B, right? So 1/2 times 1, and then we're trying to solve for that v squared, and then plus 1, which is mass, times 10, and the height is 0. Hey, we like that, right? We don't need that right there. Let's cross it out. Okay, and so we're solving this out. I usually do the algebra right in my calculator. That's why you have those Texas Instruments calculators. So if you're going to plug that in your calculator, you take 1/2 times 1 times 4, or 2 squared, plus 1 times 10 times 10. Times 2 divided by 1. You don't need a 1 in there now. And that will be equal to v squared. All right, and then you'll take the square root of it because there's a square there. All right, so I am going to punch this into the old calculator. I didn't have it with me, that's why I had to take a little pause there. Punch this into the calculator, so I'm going to say 1/2 times 4 plus 100. All right, and then push equals. And then we're going to times it by 2, divide it by 1, and then push equals. And I'm going to take the square root of that baby. I got 14.2. So I have my velocity. Oops, wrong marker. So I have my velocity at B. Let's call it the VB. 14.2. Looks good to me, right? All right, now let's find the velocity at c. Now c's not going to be going as fast, right, because it's higher. But we're going to set this up the same exact way. So we have 1/2 times 1 times 2 squared plus 1 times 10 times 10 plus 0. Okay, now, if you're confused what I just did there, I just copied this exact same thing because that car, that roller coaster car, is still starting at the same spot. So why not use that same thing for the next section? The only difference is we're not ending in the same spot. So let's put it at some other spot. So we have what happened there? 1/2 times 1. We still don't know velocity squared. Plus this time we have 1 times 10 times 3 meters high. Okay, so punching this into the calculator. You know, I just punch these into the calculator just plain. But here's what I'm going to do. I'm going to take these. I'll take it all. Oops, see what happened. Copy. Paste. Okay. Now, that's that, right? I have the 0 on there, right? And I'm going to make that. And then I'm going to subtract this. Right? Because it's added on this side of the equal sign. So I can subtract it on, well, you're doing it on both sides, but I'm going to subtract it on the other side. I'll put that down. Oops, quit growing on me. I'll put that right there. All right? I should have copied it. There we go. Nah, just so it doesn't mess up the whole show. All right, and then make that equal to what we're trying to find there. I hope I have that 2 in my thing. I'm pretty sure I do. Okay, see how I did there? No, that's just resolved. In class, I wouldn't do that normally, right? But we'll just do it here for fun here. So we're solving for v squared, right? Now, we're multiplying. So now we have to go, all right, so we have the 2's on the bottom. Let's change back to a color, right? And that's a 1. We don't have to worry about the 1, right? And then we have that square root. So what we're going to do is we're going to do our math on this side first. Let's do it on the yellow side first. I say this side, but you can't see me, so I'd say yellow. So I'm going to punch that in the calculator. And I got 72 over here, right? So 72, and then I'm going to times that by 2. And that equals 144. And then I'm going to take the square root of 144. And that's 12. We knew that anyway, didn't we? Oopsie. So VC equals 12 meters per second. That was a pretty number. Love it when they're nice and pretty like that. Okay, so there we have that. And that makes sense because look at this one. This was 14. So being 12, it's going slower. That makes sense. All right, next one. Hey, guess what? That roller coaster still starts in the same spot. Let's look at the picture before I rewrite. But this time we're going to try to find the maximum height. So the maximum height is the point where the velocity equals 0. Capiche? Cool. Here we go. So we're going to do the same exact thing we did here and here. So it's 1/2 times 1 times 2 squared plus 1 times 10 times 10 plus 0 equals, now we're at this right here, we're at 1/2 mv squared. And I'm going to highlight it in orange up here. I'm right here, right on the equation. Velocity 0, right? Velocity 0. Pop a 0 in there. plus the mass, which was 1, gravity, which was 10, and then we're solving for the height of that roller coaster. All right, here we go. I'm just going to do the answer. If you can't figure this out algebra-wise, you'll be able to do it. Just keep doing it until you get the right answer, and then whatever you did, then that's how you're going to do it from now on. I got 10.2 meters high. And that's it. That's the roller coasters. Let's highlight that in orange to make it match everything else I have in orange, right? So then I took 1/2 times 1 times 4 plus 10 times 10, and then I divided by 10, and that gave me my answer. All right, that should be it. Any questions with that? Let me punch that in one more time before I say goodbye, but I'm saying goodbye. If it doesn't work out, then I'll let you know. Bye.